Welcome to Session 9, Circumference. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to interpret circumference as the perimeter of a circle. Choose efficiently between C equal PD and C equal 2 PR. Separate circumference in linear units from area and square units. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The circle area covers the interior and uses square units. The circumference is the circular version of polygon perimeter. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. A bicycle wheel with diameter 0.7 meter travels about 3.140.7 equals 2.198 meters in one full rotation. 10 rotations cover about 21.98 meters, connecting circumference to distance traveled. Circumference is circular perimeter. The formulas pi times diameter and 2 pi times radius are equivalent because the diameter is exactly twice the radius. Estimate with a nearby rectangle or familiar benchmark. The estimate does not replace the exact calculation. It tells you whether the exact result belongs in the right neighborhood. Now add a precision check. For every area or boundary problem, identify exactly which segments form the base, height, radius, diameter, or outside edge. Convert units before combining measurements, keep full precision during the calculation, and round only once at the end if the context requests a decimal result. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, identify whether the given center-to-edge length is a radius or the edge-to-edge length is a diameter. Second, use the formula matching the given measurement to avoid an unnecessary conversion. Third, multiply by pi, round as directed, and attach plane units. Finally, estimate the circumference as a little more than 3 diameters. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. A circle has diameter 12. Using pi equals 3.14, what is its circumference? Step 1 is to organize the information. Identify whether the given center-to-edge length is a radius or the edge-to-edge length is a diameter. Step 2 chooses and sets up the relationship. Use the formula matching the given measurement to avoid an unnecessary conversion. Step 3 carries out the mathematics. Circumference from diameter is pi times diameter, 3.14 times 12. The answer is 37.68. A useful check is to circumference is a length around the circle, not area. The answer is 37.68. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. A circle has radius 9. Using pi equals 3.14, what is its circumference? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 56.52. Circumference from radius is 2 times pi times radius, 2 times 3.14 times 9. The answer is 56.52. A useful check is to circumference is a length around the circle, not area. Use this coaching check as well. Use the 3 diameters estimate. If your answer is nowhere near 3D, check whether you confuse radius, diameter, or area. Session recap. First, identify whether the given center-to-edge length is a radius or the edge-to-edge length is a diameter. Next, use the formula matching the given measurement to avoid an unnecessary conversion. Then multiply by PA, round as directed, and attach plane units. Finally, estimate the circumference as a little more than 3 diameters. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.